Yeah, I think like I originally joined Web3 because I was mostly curious to know more about Ethereum. So I was fascinated by the idea of self-sovereign application, unstoppable application that can run off this kind of gigantic computer that cannot be stopped. And I was curious to build something. I didn't really know what to build, but I was just curious to build something. And I think like the best thing that happened to me, but I think is general for the whole Web3 community, is that it's a very open community. So even if I didn't really come with like some crazy background or like crazy skill before starting, I was accepted, like I was helped in learning, and I think in the meanwhile I discovered what was the area that interested me the most. It was like related to ZK, indeed, and I think I started with some hackathons and I kind of joined some Telegram groups. So it all started very kind of organically, and I wouldn't say that I reached my goal, but I think I started with a very kind of broad goal that wasn't really clear, and now I'm getting more specialized in some area. So I think I don't know what will be my end goal, but I'm having fun in the while. So the first thing that can come to my mind when I think about crypto is the concept of private key, like public key, private key pair. And I think this is really important because, so for example, what I do in my job is kind of generating proof related to something that you do on chain and something that basically any action that is performed by some person. But the cool thing is that whenever you perform some action using your private key, so it can either be signing a transaction or even signing a message that doesn't get broadcasted on chain, whenever you sign something, basically this has some cryptographic trace that can be verified against. So everything that is signed, you can generate any kind of proof that you want. You can do everything when something is signed, and that's a big difference. The first thing that comes to my mind when I think about Web3 is the concept of private key, especially the concept of having a pair of private key and public key. And this is really relevant for my job, especially because whenever something is signed, whenever you as a person, as a user, sign something, either can it be a transaction or just some sort of message, there's like a cryptographic proof that this thing existed, that you did something, that you performed some action. And so you can easily verify things against this because there's like a cryptographic trace that this happened, that this existed. And this is opposite to the Web 2 world, where everything, basically every action that a user performs, just live inside a database, inside a server of a centralized institution. And the problem there is that the existence of this fact inside the database of the centralized institution can easily be manipulated by the centralized institution. So yeah, it's like this data never existed, because if you cannot trust that the data was actually coming from a person, it's useless. So I think the cool thing about Web3 and blockchain is the fact that we are giving to any user some key, and starting from the action that are performed using this key, we can build a lot of cool system and applications. Yes. Yeah. Like being a ZK circuit engineer might sound very abstract and philosophical as a definition, but basically it just means like writing code that is not for a normal type of program. So a normal type of program might be, I don't know, some server or any backend program. Like it's writing a program that is more compatible with the ZK as a system. So basically it has some more specific requirement. So basically every time that you write a ZK program, it means that you need to define constraint. So it's a constraint system, and everything that you prove inside the ZK program needs to be constrained against some rule that you define a priori. So basically it means like defining the design, the requirement of the ZK circuit, what needs to be proven inside this circuit, and then writing this constraint in a language. So it's like I started using Circom, which is a specific language to write ZK programs, and now I moved to Elo 2. There is not really a language, the language itself is Rust, but it's like a library built on Rust. But there are many other tools, like there's one built by Aztec that is called Noir, and they all help you write ZK programs, ZK circuits. And the cool thing is that they are built such that you don't really need to understand everything that is happening behind, like the math, like all the things. So if you are kind of able to accept it as a black box, you can be a ZK circuit engineer without having to do all the academy, all the research, mathematics that there's in the background. I think like one of the coolest application and use case of ZK that has been built recently and is not yet mainstream, I would say, is a field called ZKML. ML stands for machine learning. And the cool thing here is that I think there are like two ways of applying ZK to machine learning. Like one is proving that some sort of machine learning model was trained on some set of data. So maybe you as a machine learning developer want to prove that you haven't trained your machine learning model on some data that belongs to someone else, or there are maybe some regulation in place that force you to not use some data. And using ZK, you can actually prove that this model wasn't trained on some specific data set, which is an application. And also another application is more on using ZK to verify that the output you get from a machine learning model is actually coming from that model. So for example, when you're using like ChatGPT online, you see like GPT 3.5, GPT 4, but you don't really know what's happening in the background. And for example, they might use a worse model like GPT 2 because it's more cost efficient for them. And you will never know if this is coming from GPT 2, GPT 4, GPT 12. But using ZK, the ML model creator can actually commit to the values of the model. It's like the hash of some source code, for example. And every time that you get an answer from this ML model, it's not only language model, it can be whatever model. You can also get a proof attached that is saying that this is coming from this model specifically. So I think this is also not very known in the ML space, like the non-ZK ML space, but I think this will be very relevant in the future.